Now let's look at some of the application problems. The first one here is just a problem where we're trying to solve a triangle. You do have to know how to draw the triangles the way that they're expecting you to. So this tells you that you've got sides A, B, and C, and the right angle is at C. I'm not trying to draw this to scale or anything. Just putting in my right angle at C, and that means side C is across from that one. And then I've got angle A over here. Side A is across from that, angle B, and side B is across from that angle. Now I can label the side lengths that they gave me. They said that side A was 10 and side B was 24. And I want to solve the triangle, which means I want to find all of the unknown side lengths and all of the angles. I do already know that this angle is 90 degrees. So I have one side to find and two angles. To find side C, I could just use the Pythagorean Theorem, since I have two sides of the triangle. That would give me 10 squared plus 24 squared equals C squared. 10 squared plus 24 squared is 676. This time I don't have to worry about a plus or minus for this answer since it's a side length. It has to be positive. The square root of 676 is 26. So that's my side length for C. Now to find my A and B angles, I can do the same thing that we did in the last problem. That is, I can use a trig ratio with either angle to find the angle using the inverse trig function. I'm going to look at A for that one. B is the adjacent side. C is the hypotenuse. The trig ratio that relates the adjacent and hypotenuse is cosine. Cosine of A would be 24 over 26. Since I'm trying to find A, I'm going to use the inverse cosine on each side. Then I'm going to use my calculator to find the inverse cosine of 24 over 26. I'm supposed to round my answers to one decimal place. That gives me approximately 22.6 degrees. Then for my angle B, I know B and A are complementary since this is a right triangle. So B would just be 90 minus 22.6 degrees, which gives me 67.3 degrees. Here's an application problem that deals with bearings. And in this one, remember, it's really important to try and draw the picture correctly. It doesn't have to be super accurate, but it should be somewhat. First, we have the rowboat leaving the dock and going in the direction of south 29 degrees west. Here's due south, and if I'm going west from there 29 degrees, that would be something like this. And then in that direction, it travels 3.2 miles. The boat turns and goes 4.6 miles in the direction north 61 degrees west. So from here, I've got due north, and I'm going 61 degrees west from there, which would be about like that. And this one is 4.6 miles. There's my 61 degrees. And then I'm trying to find out how far the rowboat is from the dock. So this was the dock, and this is where the rowboat is now. What I'm trying to find is the length of this side over here. All right, so I do have a triangle. I can use some of my geometry facts. Since this is due north and this is due south, and these two are parallel lines, I've got a transversal here, so that means if this angle is 29 degrees, then this one also has to be 29 degrees. And 61 and 29 add up to 90 degrees. That means that this angle right here is actually a right angle. I'm going to redraw my triangle because it's kind of hard to see in here now. So here I've got the 4.6 miles. I have a right angle here, and this side is 3.2, and I'm trying to find the length of this side over here. So really I just have a right triangle, and I can use the Pythagorean Theorem. I don't have to use the fact of these angles at all, except that those two added up to 90 degrees. That's what gave me my right triangle. In this triangle, this side is the hypotenuse, since it's across from the right angle. So I would take the 4.6 squared plus 3.2 squared would equal my x squared. Squaring those two and adding them gives me 31.4. Then I'm going to take the square root to get my answer. So my answer for x is 5.6. That would be 5.6 miles since everything else was in miles. One more application problem. In this one we have a boat that's spotted from the top of a 150-foot tall lighthouse. The boat is 50 feet from the base of the lighthouse. So for my picture, I've got my lighthouse that's 150 feet tall, and then my boat is 50 feet from the base. And what this is asking is to find the angle of depression from the top of the lighthouse to the boat. Remember, for the angle of depression, you're always going from the horizontal down. So if this is the top of my lighthouse up here, I'm looking for the angle that this makes with the horizontal. So I'm going to call this D for my angle of depression. So to find that one, I could find this angle. These two would be complementary since this right here would be a right angle. If I want to find this angle, then looking at my side lengths, I have this over here that's would be the opposite side. This would be the adjacent side. So I'm just going to call this angle A. So that means the tangent of A would equal 50 over 150. I'm trying to find the A, so I would do the inverse tangent on each side. Plugging that in my calculator, 18.4 degrees for A. Now I was trying to find D, which is the complementary angle to that, so I'm going to subtract that answer from 90 degrees. That gives me 71.6 degrees. My angle of depression is 71.6 degrees.